Hello everyone, this is Ritu Sharma and I'll be talking about my project, Minutiae-based fingerprint recognition and matching. This is for EEL6825 pattern recognition at University of Florida. Finger, Fingerprint recognition is most widely used biometric. It can be classified into verification and identification. The verification system either reject or accept the match. Rejection or acceptance threshold is set by certain mathematical calculations, and these thresholds are required because the fingerprint algorithm is based on image processed. So there are basically two types of fingerprint algorithms. There's a correlation based and there is a minutia based. In correlation based, we select a template for a fingerprint and we compare it with the fingerprint of another image. In the minutia based, we process the image in order to get certain parameters that are useful to perform recognition. This identification is made on the basis of curves, ridges, and several other unique features. Here, minutia is very important feature for identification as no two fingers have identical minutia. Further, both the algorithms have certain pros and cons. For correlation based, it works. The pros is that it works fine with the bad quality picture, and it's very sophisticated. Whereas the con is that as it's very sophisticated. It involves a lot of comparison. Whereas in minutia based, the pros is that it's very simple and it's very easy to implement, and whereas it does not give us 100% of accuracy as it depends on the image quality. My implementation is in 4 stages. The first stage is converting image into binary matrix. In this step, pixels are classified in range of shades of gray, 0 being black and 1 being white. All the intermediate values are represented in the shades of gray. Formula is given here to average out the red, green, and blue intensity. We can further see this in programming implementation. So here we have the image with different colors. My aim here is to show the difference in the shades of gray after the conversion. The file is created. After post gray scale, we can see here that each word has different color. Now moving on to presentation. Next process is thinning process. In this process, pixels from the matrix generated above are removed. They are removed from the corners, boundaries, and they are removed until a single pixel width image or a skeleton is generated. Again, we can see this in our program. Here, this time I'll use an actual fingerprint. This is the fingerprint and we will see the converted image. On execution, one. Okay, I gave the wrong name. Alright, so file is created. Going there. After post scale. Here, this is the image after thinning. Here we can see that the width of the walls and all the minutiae is singular. Now, moving on to presentation. So the third step and the most important step is minutia extraction. After thinning of the image, all the minutia from the fingerprint skeleton is extracted using the Ritowitz crossing number, using the formula of Cn, which is given here. Here Pi is the binary pixel value in the neighborhood of P, with Pi is equal to 0 or 1 and P1 equal to P9. Crossing number is used to classify the pixel. Here we can see that if crossing number is 1, then it's a termination point. If the crossing number generated is 2, then it's a normal ridge pixel. Whereas if it's 3, it's a bifurcation point. We can see the image after the step 3. So moving back to the code execution, for the same image Samantha 1, we will again execute and we will see image conversion after the generation of crossing number. Here post min extraction png. So this is the image that we are getting, and I'm representing each of these with different color intensity, red, green, blue. Each can be seen as the pixels generated from the crossing number. Moving further back to the slide, so the final step is step 4. Final step is of generating matching score, which is given by false non-matching ratio FNMR formula. It's a division of false non-matches divided by unrolled attempts, which is calculated here in my code, which we can see here. I have to comment it out. It has been calculated here. It has been calculated as the total matched minutia divided by the total number of minutia compared minus skipped minutia. Skipped minutia are the minutia which does not have the corresponding minutia pair. So again we will compare the two images and we'll see the execution process. Here I'm taking two images of the same person. Here Samantha 2. I'm comparing this image with this image. This fingerprint is of the same person and we should get a good matching score here. So minutia is this much in first pick, is these many in second pick. There are sample missings of 735 because both the images are taken with different angle and they have few spots missing there. That's why there is a sample missing. These are the compared sample. The matching score shows 77.4864%, which is a good score. On an average, successful matching score is approximately equivalent to 75%. We can also see two non-matching images. Here I'm comparing one.png with my roommate's impression, which should not verify and it should be below 75%. Here we got 59.890%. Again, the first and the second image is taken from the same person and it should result in a good matching score. So if we compare first and the second PNG, we should get a 75% above matching score here. So it's an approximately close to 75%. It means it's a successful rate. So likewise, we can compare all the images and see the execution output. There are certain observations which have been realized after the execution of a lot of samples. The successful match score is approximately greater than equal to 75%. The number of sample missing is directly proportional to the difference in the number of minutiae in the figure. I have also drawn a graph based on the output generated from all the samples. There's also the more the minutiae are calculated for better quality of picture. So if the quality of picture is better, the calculated minutiae are more. Further, There are certain future improvements scope. One of them is C++ implementation. My current implementation is in Java, which is slower compared to C++ because C++ runs on the natively instead of virtual environment. Another thing that can be done is in the parallel algorithm, in which sub iteration should go on until single pixel is left. This approach is well suited for real-time processing of fingerprints. Here, somehow, I'm unable to remove some noise at certain pixels. We can also include more islands, bridges, spurs. Right now, we just have valleys and termination points. We can include more images. So, to conclude, this attempt was to provide a reliable solution. It proposed solution is efficient enough to give a satisfactory match score, and however, the match score will be much more close to verification if the quality of image is better. So the approach presented is dependent on the quality of the image. Thank you.